Okay, welcome 1430 class. My name is Dave Schwartz. Today we'll be reviewing section 3.4, which talks about marginal revenue and marginal cost and things like that. So I've got one problem to do on marginal revenue. So let's take a look at this problem I have on the board. It says the marketing department has determined that the demand equation for speakers this is a little p. So little p means price. And it's equal to negative 0.04x plus 800. This is the implied domain. X is going to be greater than or equal to 0 speakers and less than or equal to 20,000. That's the implied domain they give us. We really don't have to worry about that. Where little p denotes the speaker's unit price and X denotes the quantity demanded. And here are the three questions. Number one, find the revenue function R. And then B, find the marginal revenue. I underline that because at this point we should know marginal revenue really means R prime. We want to find the derivative of the revenue function. So the word marginal means find the derivative of whatever function. And then finally for part C, we want to compute, this is an E here, compute R prime of 5,000. So we're going to find R prime of X in part B, then we're just going to input 5,000. And then we want to interpret the result. And as I'm thinking about it, exam number 1 is going to be next week, Wednesday, September 16th, and it's going to be on WebAssign. Make sure you have that lockdown browser. And no webcams are needed for this course. No webcams are needed. All right, so let's get to the solution. For part A, to find the revenue function, let's know this formula. R is equal to P times X. So we should know that. You can write that down so you can have it for your test. Okay, so R, if we want R as a function of X. So I'm going to write R of X just for fun. You could just call this R if you wanted to. So if I want to get R as a function of X, I must replace this P. And look at over here. What's another name for little p? This expression of X. So now I'll get a function of X. So in place of P by substitution, let's write negative 0.04x plus 800. So that takes care of this P. And then don't forget we got to write times X. It's all of this times the X. You must have parentheses, otherwise it's wrong. Okay, and now let's distribute this X to simplify. So negative 0.04x squared plus 800x. So this is my answer for part A. We have the revenue as a function of X. So we just found the revenue function in terms of X. Okay, for part B, we want to find the marginal revenue. So just take the derivative. R prime of X is equal to, and I'm going to do it the quick way. Don't do the 4-step process because they don't tell us to. So the quick way is the power rule for this term and then the power rule here. So derivative plus derivative. So when I bring down the 2, I get a negative 0.08x plus, and then the derivative of 800x is just 800, the number in front of x. So there's my answer to part B. That was quick. That is the marginal revenue. And then finally for question C, compute R prime of 5,000. So wherever you see x, you're going to write 5,000. And that's going to equal negative 0.08 times 5,000 plus 800. So you could do this on paper, but you're allowed to use calculators. So let's use a calculator. So I got my answer written down here. So if you go negative 0.08 times 5,000, you are allowed to use calculators. So have a calculator with you. So this is going to equal a negative 400. That's what this product is. And then we got to write plus the 800. So that's going to be equal to $400. Remember, derivatives are rates, so it's dollars per unit. That's the rate. Because derivatives are slopes. Think of slope as y over x, where x is the units and y is the price. So dollars per unit. So that's our answer for part C. And then finally, we want to interpret the result. So this says that when the level of production is 5,000 units, the production of the next speaker will bring an additional revenue of $400. So that's what that means. Okay, so hopefully that is good for you, and talk to you next time.